Hey everyone, and welcome to your C++ tutorial on vectors, or as any sane person would call them, dynamic arrays. So let's begin with definition for a vector. Like I said before, a vector is a dynamic array, meaning it's an array that can change in size. So as you might remember, previously when we created arrays, we had to define a size right up front. And the compiler will give us enough memory to accommodate that size array. Vectors, you don't need to do that. Vectors have a dynamic size, meaning that they can expand and contract as you add items to them. It's pretty useful, but also compared to an array, it's very memory inefficient. So you're going to have a lot more overhead with vectors, but you get a lot more convenience functionality that's built in to this container type. So let's begin with creating a vector. So to create our vector, we first need to create a preprocessor directive here. And so we're going to include our vector file, and then we're going to use the standard library namespace. Awesome. So now we're ready to create our vector. So this is the syntax for that. We're going to start with the vector keyword, and we're going to follow it with between these two angle brackets, we're going to give it the type that we want in our the type of values that we want to contain in our vector. For this one, we're going to contain integers, and we're going to need a name now. So what's the name of our vector variable or our vector array? Let's call it Pete's Vect. Very cool. Okay, so that's basically it. You don't need to new up a vector object, and you don't need to give the vector any type of size for the number of elements you want in the vector, because the vector is dynamic. So this is how you create a vector in C++. So even though vectors are inefficient compared to normal arrays, in exchange for that inefficiency, you do get some additional functionality that can be useful in a lot of different situations. So to get into it, let's begin by how you would add elements to the vector. So what you can do to add an element to a vector is you can use the pushback method. So the pushback method will take an item of the type of the vector. So here we're using an integer because our vector holds integer types. And what pushback does is it adds this parameter here onto the end of the array. And so right now our vector doesn't have any elements, so it'll create the first object in our vector, which is now 55. Another nice feature of a vector is that it has the size method, which tells you how many elements are in your array. So what I'm going to do is I'm going to do a cout here, and we're going to print out our vector size. And I'm going to call Pete's Vect and do size. Now let's compile this with our G++ compiler, and since we've added one element, our size should be 1. Let's run our executable. Yep, oh, there we are. Well, there we have it. We have a size of 1. So now in our vector, we have one element, and that element is the integer 55. So to access an element inside of a vector, we can use our index operator in the same way that we did with an array. So we can say our 0 index here when that 0 index accesses the first element, remember. So we're going to call Pete's Vect, and we'll access our 0 element. Let's compile this and run the executable, and we see vector size is 1, and there's the vector at 0 is 55, as we can see here. Awesome. So that's how you access your elements. I'm going to put an end line on both of these so that we get a new line after them. Perfect. So the sort of sister method to pushback is the popback method, whereas pushback will add an element that you pass into it onto the end of the vector. Popback removes the last element of the vector. So we will say Pete's vect popback will pop the last element, which is this 55, and then we will Pete's vect, we will push back and add a new element of 101 to the end of the array. I'm going to copy and paste these two lines here so that we can see kind of a before and after of our vector. Compile it here, run it, and there we have it. So we have our size of 1, and then our first element here is 55. Then we pop back, so we popped the last element of the vector, which is our only element, and we've added a new element, which is 101, and we see that here. So that's an example of the pop back function. Okay, so let's take a look at another good, I almost said fun, I don't know if it's fun, but a good, a useful method that a vector has, which is the empty method. So is vector empty? So we're going to access Pete's vect, say empty, and what empty does is empty will return us a true or false value or a Boolean of 0 for false, 1 for true, to tell us if the vector has any elements in it. If the vector is empty, it will return a 1 for true. If the vector has any elements in it at all, it will return a 0 for false. So I will also add an end line onto this. So right now our vector has an element. So when we print out is vector empty, we should see a 0 for false. So we'll compile it, compile the new code, run it, and we do see a 0 for false here for is vector empty. Awesome. So that brings us to maybe our final method here, which is the clear method. So what we can do, the clear method, which looks like this, basically wipes out all of the elements in a vector. And so if we can maybe print here the vector is cleared. And then let's print out we'll print out empty again. And we'll see if we still have elements or not. Run the executable. We see is vector empty is 0, right? Because it has elements, so that's false. So there are elements in our vector. We clear the vector and we check is the vector empty, and we're getting a 1 now for true. So we can see that the clear method removes all of the objects from the vector. Another method I'd like to discuss with you is the at method. And this is a really useful method because it works the same way as using this index operator, but it's a little bit more stable. So if we print out, actually, you know what? Let's push back another value onto our vector, and we'll say this is 200. And so then let's print out the 0 element using at. And so what at looks like is you just use at, and you give it the index in the same way that you would with a normal array using those straight brackets. So let's print this out and see what it looks like. We'll compile it with our G++ compiler. Let's run the executable. So here we have 0 element at using at, and it's 200. Perfect. So that would work the same way as if you used the index operator. However, with the index operator, you're accessing that index directly. So if you do something like delete the index, or really if you just delete the index, or if you use an index that's outside of your array or your vector, you're going to get whatever value is in there, which might not even be a part of your vector. Whereas, so if we do something like we check our Pete's vect and we clear it, so we use clear here. If we take this and we copy and paste it here, I'm also going to do another print line here to symbolize that we cleared the vector. There. So let's compile this new code and run it again. Awesome. So down here, we have 0 element using vector. It was 200. We cleared the vector here on this line, and then we tried to access an element that no longer existed using the at method. And we terminated our program with an uncaught exception, right? So 0 elements using at, and it aborted our program. So this is sort of like, I know it looks bad, but it's kind of a more safer way to exit a program. We have an exception, it's uncaught, terminates the program, that's fine. If we used an index here, you might be surprised at what happens. So I'm going to use our index operator to pull this value. I'm going to compile the new code, print it out. 0 element using at here. We cleared the array, or cleared the vector, sorry. 0 element using index, it's 200. How does that work if there's no elements in the array? Well, when you clear the vector, you're basically just flagging that index as, empty, but you leave the data in it. So that data is still there to be picked up. But it's flagged as not part of the vector anymore. So all this is doing is it's with the index versus the at method, the index is taking a pointer and pointing to that memory location. That memory location is no longer a valid part of the vector. So if you use the method that's on the vector, it'll say, hey, you've stepped outside of our bounds right now. However, this using this index method, it's taking a pointer and pointing to that index. And so that's more of an unsafe way of accessing the data. So really, with vectors, instead of using accessing it by index in this way, you should be using the at sign, or the at method, because it's safer. And I know that throwing an exception that we don't catch doesn't seem safe because it exited our program. But in certain situations, you can catch exceptions and do things like take action after you catch them. We'll get into that later. But it is generally better to use our at method than it is to access the index directly, because you can access all types of memory that might not even be in your vector. So just to recap real quick, vectors are just dynamic arrays, or arrays that can change in size. They can expand and contract. And as they expand, they take up more memory. And as they contract, they leave more memory unused. To create a vector, we first need to add our preprocessing directive here and bring in our vector file. We need to use our standard library namespace. To declare a vector, it looks like this. You need to use the vector keyword using our straight bracket or our angle brackets here, and give it the type of data that you want to store in the vector or in the array. Then you have to give it a name, finish it off with a semicolon like every other thing in C++. From there on out, you can use pushback to add elements to the end of your vector. You can use popback to remove elements from the end of your vector. You can use the size method to tell the size or how many elements are in your vector. And you can access those elements using this unsafe way, which is to use our straight brackets and to use the index directly, or you can use our at method that we discussed down here. This is a safer method and throws an exception when you go out of bounds. There's also a size method on a vector, so it can tell you how many, or actually we discussed this, so this is how many elements are in the array. There's also the empty method to tell you, is your array empty or is it, does it have items in it? And finally, we discussed the clear method, which removes all of the elements in your vector. Okay, so that's quite a bit for one tutorial here, but this is sort of your introduction to vectors. They are not very efficient, but they give you a lot of helper functions. So if you're new to C++, that can be pretty attractive. Me personally, I prefer arrays because they're more efficient, but vectors are cool too, and I thought they were worth mentioning. Thanks.